Hello friends, good morning. Welcome back to our channel ALP Talks. This is your Lakshmipathi. Today we have our guest Mr. Chakrabarti with us. He is an electrical engineer, BTech and MTech he did. So he has good experience in power system and all the study related. So he shared his experiences. So he is he worked in solar grid tied power projects also, and some of the hash handling related NTPC projects also. So he shared some. He worked in Indonesia, some power plant related SS single line diagrams and the maintenance and some. So clearly explained all the things related to the power plant, how it will operate, what are the things are there, what are the some small procedures or steps. So grid tied in inverter, what is the operation, how it will operate. Yeah, small things we will discuss it. So in future we will make some more videos with our combination. So I hope this information will be helpful to you. Thank you. Keep watch this video till the end. If you didn't subscribe to this channel, please subscribe to it so that whenever I'm uploading the videos, you will get a notification so that you can watch it. Keep watch this video. Hello.
Hello.
Yeah, Chakrabarti. How are you?
Fine. How are you?
Yeah, I am good. Nice to meet you.
Yeah, nice to meet you too.
Yeah, first time I'm watching you. Yeah,
Yeah.
very good.
Actually, I called you at 6 o'clock because you were not joining. That's why someone picked up from your side
Yeah,
and said
yes,
that you
yes.
were outside.
Yes. Yeah, due to some issue, we went outside and yeah, now okay. We are here to discuss.
Yeah.
Welcome to our channel, ALP Talks.
Yeah, I have seen videos in your channel and I also follow you on LinkedIn. You
Very nice.
ask very intelligent questions about electrical design engineering.
Yeah. It's almost most of the electrical stuff I'm just trying to cover, and simultaneously the industry experts who are there, who are working maybe more than 1 or 2 years, they have some good exposure in the industry. Those things we don't know. All the other students or professionals, they don't know about it. What's going on in actual. So like that. So it's good to share their experiences so that people can understand it, they get benefited. So that's the reason I started this channel. It's going well. Yeah, nice. Like the people like you, so many people are sharing their knowledge, and it's going well. Yeah, thank you. Thanks for accepting this call and attending. Yeah, it's your turn, Chakrabarti. So let's speak a few things about you, who you are, and what's your educational professional background, so that we can discuss some stuff. It may benefit many professionals.
So basically, I am a BTech MTech electrical engineer.
Yeah,
Completed my BTech in the year of 2011,
yeah.
and then I started working for DC Industrial Plant Services. It's a development consultant group company.
Mm-hmm.
Basically, they were doing EPC for ash handling system in power plants.
Okay.
So while working there, I started doing my MTech also. Like
Uh-huh.
in the morning, I went for job, and in the evening, I went for class.
Very nice.
So I completed my MTech in power system from Rajavaja Science College. It's Calcutta, under the Calcutta University.
Hmm?
So it was completed in the year of 2015.
Okay.
Okay. Then after the completion of MTech, so I thought that maybe I'll be moving to teaching profession. So
Yeah.
for 1 year, I went
Yeah.
to a college,
Yeah.
and for 1 year or for less than a year, I think I was
Yeah.
teaching processing there.
Mm-hmm.
Then I got the opportunity to join Development Consultants Private Limited, which you
Mm-hmm.
know is a reputed design engineering company.
Yes.
And I joined there in the year of 2016, and
Okay.
then from then till today, I'm
Yeah.
working there.
Yeah.
So basically, the sale there are a lot of sales in our company. I mean, like chemical,
Mm-hmm.
power, architecture,
Yeah.
nuclear.
Yes, yes,
So basically what they do is like they design plants, buildings, bridge, etc,
yeah.
etc.
Okay, okay,
So presently I'm in technology control cell. This
okay.
particular cell do serve different jobs like power plants,
Mm-hmm.
cement plants, chemical
Okay,
plants.
okay.
So basically, what I do is I design the power system and
Mm-hmm. Okay, okay. Very nice. So you have a good exposure on power system and all.
see, power system is a huge subject.
Yeah, yeah, yeah,
So nobody can tell that he knows 100% about power system.
yeah, yeah.
But
And
since
that's
I
the
love it,
that. Yes, yes. That.
and also one thing I want to tell that I don't know about other states, but in our state, in the BTech, like the BTech syllabus for electrical engineering, it covers only like 0.1% of what is actually in there. The real knowledge starts once you join the industry.
That's true. That's true.
The real experience starts when you join the industry, because there is a hell and heaven difference between the theoretical side and the practical side.
That's
Yes,
true.
for design, you have to have a good theoretical background,
Yeah,
but
yeah.
still it is different. And during my MTech, I have learned a lot of things which was not covered in BTech
BTech.
syllabus. Yeah,
That's true.
like most difficult part of power system is the protection, like
Yeah.
protection engineer,
Yes,
power
yes,
system
yes.
protection.
Yeah, yeah.
Lot of things are there. I do not even know everything of that. Like there are transformer, generator, motor, transmission line.
Yeah,
Lot of things are there.
yeah. That's
So
true.
yeah, every day I'm learning. I mean, every day I'm learning.
Yes, Chakrabarti, that's true. Today, I mean, we should be better than tomorrow, yesterday, and tomorrow we should be better than today. So
Yeah,
that we should keep in mind. We always because the technical field is completely. We should always aware things, and we should always grab new things. Then only we should better survive in this field with good
yeah,
maturity of knowledge and all. It will help us maybe financial also. It will help us to reach a good climbs. Simultaneously, mentally also it gives some good peace
yeah,
of mind
yeah,
also. Yeah.
yeah,
So the people who are always ready to learn something, then they are always very good. Yeah, very nice. Yeah. So your MTech also, I think, is helping your job and all because the profession because you studied more things in the MTech.
yeah, 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 yeah.
Very good, very good. So after the assistant professor, so how you feel teaching is difficult, teaching is easy? What
Well,
you say?
actually, in the teaching profession, that is a bit different because it only focuses on the book. The knowledge
Mhm.
is all about bookish.
Yes,
So
yes,
when after working for a EPC company for like 5 years, when I went to teaching profession, it was a very short span of time, like nine
yeah,
or 10 months or so.
yes, yes,
So
yes.
what I saw there is that the people who were teaching, they were only focusing on the book, because some of them had practical knowledges in the field, like
That's
what
true.
exactly is happening,
Yes,
but
yes,
most of them they were only focusing on the book. But
yeah,
I had a little bit of advantage, though I don't know everything, but I had a little bit of advantage because I have seen the industry. I mean,
yes, yes,
when a motor is running in front of me, I know what is happening, what is not happening.
yes, yes.
So
You know the
that makes a
things.
little bit of difference.
Yeah, yeah.
That makes a little bit of
I
difference.
think your teaching skills are a little bit different. I think the students also maybe enjoyed your presence in the class, in the good presence mainly.
Yeah, and I mean, looking from a student's side, I mean, say a budding engineer who just completed his BTech studies, and if he is going into design,
Yeah,
so first of all, I think, according to my experience, he need to have a like very much clear idea about the theory. Like a small example.
Yeah.
Like if you are doing something like transformer sizing calculation, so he must know, he should know transformer. Electrical engineer must know what is a transformer.
That's true.
But what is its KVA? What does it mean by KVA? This
Yes.
this needs a little bit of idea.
Yes, yes,
Then
yes,
after
yes.
that,
Yeah.
there are a lot of detailing which needs to be done. So
Yes,
things are
yes,
like
yes.
this.
Yeah. Yes, yes, yes. That's true. That's true. Okay. So let's good. You have shared good things about your thinking way, how things are there. Very nice. So let's discuss few things about, for example, at Nalco you have some experience like solar related. Can you speak few things about
What?
that? At
What?
I think I'm just digging into the topics. You have some exposure at Nalco, right? I mean, so what is the work you generally? What type of work you did for that?
Actually, that particular project you were talking about is basically that was for National Aluminium
Mm-hmm.
Company, Nalco.
Yes, yes, yes.
And
Mineral company. Yeah.
they had a research and technology center which was being developed at Orissa.
Okay.
Orissa.
Okay. Okay. Mm-hmm.
So there they were making a R&D center.
Okay. Okay.
So the job, our job was to design that particular R&D center from greenfield. Actually,
Okay.
lot of
Okay.
facilities were there, like
Mm-hmm.
testing labs were there,
Okay.
and
Okay.
mm, and also other facilities like big buildings were there. So we
Mm-hmm.
had to design that how much power is required for that particular
Mm-hmm.
uh, complex.
Okay.
This we had to decide and design.
Okay. Okay.
And so that was basically an architectural project.
Okay. Okay.
Architectural project.
Mm-hmm. Okay.
Uh, and looking from critical point of view, like so a power plant is a typical. I mean, when we are designing power plants, it's
Mm-hmm.
basically a typical thing. Like there will be a generator, transformer. But while doing architectural projects,
That
the
is
difficulties
different.
are more because no one gives space for electrical things. Like the building will be looking like this, but no one thinks about how much power it will be taking, where will be the electrical substations and all.
Yeah. Yeah.
So looking from that point of view, it's a bit difficult.
Yes. Yes.
And I
Yes.
also, if you look at my resume, I also went Indonesia.
Yes. 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 Yes.
That
Yeah.
particular company is April Asia Group.
Mm-hmm.
It's like the world's second largest paper producing paper
Uh-huh.
plant.
Okay. Okay. Uh-huh.
Okay. Not only
Okay.
paper, presently they are doing rayon fiber or something like that. They're
Okay. Okay.
producing,
Okay.
and it's a huge plant.
Mm-hmm.
And they, one thing is that they do not take power from grid.
Okay.
They have own power island inside the plant,
Okay.
which not only feeds the plant machineries, but it also feeds the township where the
Okay.
people who are working in the plant lives, and
Yes.
it's
Yes. Yes.
huge.
Yes. Okay. Okay.
And I went for a project. They were setting up a 100 megawatt back pressure turbine generator.
Okay. Okay.
Turbine generator number 8.
Okay. 8 means what?
Okay, so turbine generator number 8, like they had like 7 turbine generator already installed there.
Uh-huh.
So
Okay.
they were
Okay.
installing turbine generator number 8.
Okay. Okay.
So like DCPL had the consultancy service for the
Okay. Okay.
whole plant actually. So I was
Mm-hmm.
deputed there for like 3-4 months
Okay. Okay.
to do the electrical
Mm-hmm.
drawings and all, get the
Okay.
approvals.
Okay. Okay. Yeah.
So the system was like it was 100 megawatt generator. It was, after that it was getting directly connected to the generator transformer. I
Okay.
do not remember the
Hmm.
13.5 kV to 150 kV. Like generator side was 13.5 kV, something
Yeah.
like that,
Yeah.
and
Okay.
it was getting the high voltage side was 150 kV. It was getting connected to a GIS,
Okay.
and that was the main bus bar where all other 7 generators were connected.
Okay. Yeah.
Okay. So,
Chakrabarti,
like other thermal.
one thing to ask
What?
you. One
Yeah.
thing to ask you. For
Yeah.
example, you told that already this is for industry only. Whatever the
Mhm.
industry, paper plant industry is there, they are using this power for the industry and nearby
Yes.
localities. So,
Yeah.
is this need the need for stepping up to 150 kV? For example, all generally generators will generate maybe the 3 kV, 1 kV to around 30 kV. Generally, that is the generation voltage range in the worldwide.
No,
So
actually,
why we have to
why,
step up it? Because
yeah,
most of the loads will be almost again 6 kV motors or 11 kV motors or something. Beyond that, it may not be there. Is there a need for stepping up? What is your observation?
yeah, I think one reason was that since the plant was huge,
Mm-hmm.
there were, I mean, not only it was producing paper, the plant was also producing rayon fibers also.
Okay.
So huge machineries were there. So
Okay.
voltage levels were like 6.6 kV was there, 11 kV was there.
Mm.
So and also that was, I think, their standard, that 150 kV was their standard. So
Okay. Okay.
different alternators were there, different megawatt capacity alternators were there.
Okay.
So they were producing voltages like 13.5 kV, some
Yeah.
like 21.5 kV or something like that.
Yeah. Yes. 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 Yes.
So everyone was stepping up to 150 kV, and from that 150 kV bus bar,
Yeah.
they were like stepping down to 33 kV,
Yeah.
11
Yeah.
kV, 6.6 kV,
Okay.
and for distribution supply for 15 volts, something like that.
Okay. Do you think that they are exporting power to grid also? I mean, other than the locality?
Yeah. Actually, they were planning to export their excess power to grid
Mhm.
also,
That is the, I
and it
think, that
was,
is the case. Then only they need 150 kV or something
yeah,
because exporting to
and
grid.
also it was like the those turbine where the turbines in that plant was driven by the process steam.
Yeah.
Like it
Yeah.
was a back pressure turbine.
Yes. Yes.
The process steam requirement was like medium pressure and low pressure. So
Okay.
what happened was high pressure steam entered turbine,
Mm-hmm.
and when it was expanding and reducing its temperature, and it went to different process activities.
Yes. Yes. Yes.
The process was like this,
Yes. Yes.
and they were producing this mm, like the fuel for that this plant. They were generating it from some
Coal.
kind of pulp making mixture or something like that.
Yeah.
Not coal, not coal.
This
It
is
was not coal
this is
fire.
the advantage for some of the factories. In, for example, sugar factories use the bagasse or molasses and all for the as a heat producing content for the boiler. Here also, I think whatever waste or something is coming from the pulp factory, they may be using that, right?
Yeah, and this was my first power project. I mean, I went
Yes.
there.
Okay.
Actually,
Very
I
nice.
had a pretty good idea about what happens in a power plant, because I
Yes.
was
Yes.
not directly involved in any other power project. So this was
Yes.
my first time.
Yeah. Yeah.
So I was a little bit of afraid, like what will
That's
be,
true. That's true. That's
what I
true.
will be doing there, what I will be.
It is like a tour to
But I
you.
learned a lot of things. But I
Yeah.
learned a lot of things,
Yeah.
like
Yeah. Yeah.
when some confusion, because the most important part was the power evacuation from generator to that particular 150 kV GIS bus.
Yes. Yes.
So when I was looking at the key single line diagram for that system, lot of confusions were there.
Yeah.
So
Yeah.
I came to
Yes.
my guest house and studied, and then
Yes, that's true.
went
That's
next
true.
day. Like in this way, it sorted out. It
Okay,
sorted out.
very nice, very nice. Yeah, yeah. Okay, so I think one more thing. You have so many experience on grid-tied solar plant related, rooftop
Yeah,
grid connected. Can you
yeah.
speak a few things about that? Those
Oh,
projects generally, what is the process and all? If customer needs something,
yeah.
so
What
how you
happens
will
is
start?
you can see there is one project going on in Kolkata. It's
Okay.
Eco Park Solar
Mm-hmm.
Dome. A
Yes.
dome-like structure is built.
Mm-hmm.
The cover of the dome is completely made of
Solar
solar, yeah,
cells.
solar cells
Uh-huh.
actually.
Uh-huh.
Yeah, if you can search Google, you when
Okay.
you write solar dome,
Yeah.
You will see that is situated at Eco Park, Kolkata. That
Okay.
particular project is carried out by DCPL. The total design engineering was by DCPL,
Okay.
and it is still in progress.
Okay.
The
Okay.
I mean,
Is this government building? Is that
yeah,
government?
it is by no, it's not a government building, but it is owned by West Bengal government.
Okay.
It
Okay.
is owned by West Bengal government.
Yeah. Yeah.
So what is happening there? Like 280 kilowatt peak, not
Hmm.
very big. The capacity is not very big,
Yeah. Yeah.
but 280 kilowatt peak for phone number of 70 kilowatt peak inverters are there,
Mm-hmm.
and the whole dome-like structure, like
Mm-hmm.
this kind of structure, it is covered with solar cells.
Yeah. Yeah.
So, and they are connected in string formation to each inverters.
Yes. Yes.
In
Oh.
string formation.
That is
String
string in
formation, they are
string.
creating.
They will be using
Yeah,
string inverter, right?
yeah.
Okay. Okay.
So, phone number of inverters are there.
Mm-hmm. Mm-hmm.
So, these 4 inverters are getting connected to one particular board.
Okay.
And from that particular board, ICV is taking power to the main MCC, which is situated in the substation building.
Okay. Okay.
Now,
Why
what
they?
happens
I
is
mean, why they need that power for feeding that park itself, or somewhere it is going?
no, since it is a grid-tied inverter,
Okay.
the concept of working of the grid-tied inverter is that it will take the voltage reference and the frequency reference from the line itself. When it
Okay.
is connected, when there is no main power, the inverter power electronic circuit will not work,
Okay.
because it will sample the grid voltage and grid frequency. It will synchronize with that, and then it will start generating. Like what
Okay.
happens is, like if you have a standalone grid tied inverter, standalone grid, you have not connected it to the grid, but you have connected the DC side with the solar cells. What will happen? The solar cells will be generating the DC voltage.
Yes.
Okay, and inside the inverter there is a big capacitor, which we call a tank capacitor. So what will happen? It basically the utility of that particular capacitor is to have a steady DC voltage.
Okay.
From that, the inverter will invert and convert it to a three-phase voltage, three-phase AC voltage,
Okay.
415 volt, 50 hertz. But these 415 volt, 50 hertz, the inverter needs continuous sampling from the grid.
Okay.
If there is no grid power, the inverter will not work.
Oh.
That's why these 4 inverters are connected to a particular bus, and from that particular bus, a circuit breaker is connected and is connecting it to the main substation MCC.
Okay.
And there is 11 kV supply. There is transformer which is like stepping it down to 415 volt. That particular MCC is 415 volt MCC.
Okay.
Which is taking power from grid. And this particular inverter side is also getting connected to the particular MCC. So what is happening is it is sampling the grid voltage and frequency.
Yeah. Yeah.
And generating power, and also like co-feeding the loads of that particular
plant.
Like, this is the philosophy. This happens.
Okay.
This is the philosophy.
Okay. Hey, what you told, like for example, if grid side supply is not there, then it won't work. The inverter setup, no.
No, it
because
will not work.
they don't
Even
have
the grid supply
sampling reference.
Yeah.
Okay.
Not only sampling, there is also one thing, like there is a window. Like 415 volt, if 415 volt is the nominal voltage, there is a window. I do not remember what is that particular,
maybe
like
400 to
percentage
400 to 430, something like that.
Yeah. And also for frequency, there is also a window, very small.
Yes, that's true.
So if the power in the grid power for some reason falls like below that window or goes to a very high voltage, the inverter will stop working.
Okay.
The inverter will stop working.
Okay, when grid power is going out due to some going down due to some issue, I mean it is disconnecting. So then still the solar power cells are all generating voltages, right? And generating the energy power and all. So
yeah.
what we have to do?
This is a very interesting question. Like when the inverter is, I understand your question. Like you are saying that when the inverter is not working, but still the solar cells are connected to the inverter DC side.
Yeah.
And like daylight is there, full sunlight is there.
Yes.
So what will happen? What I told you, that inside the inverter there is a big tank capacitor.
Yes, you told me. Yeah.
So this basically stabilizes the DC voltage.
Okay.
And feeds the inverter IGBT circuit.
Yeah.
Inverter IGBT circuit.
Yeah.
So what will happen if the power electronic circuit like IGBTs are not getting fired and the three-phase voltage waveform is not getting generated? What will happen? The capacitor will retain the charge. That's it.
That's it.
Nothing more will happen. No current will flow.
Okay. But still, whatever it is, keep on generating, means each cell maybe half amp or 1 amp. So from each DC amp generation will be there, right? Is it the capacitor is going to charge?
Yeah,
or
inside
what?
the solar cell there will be some phenomena going on.
Yeah.
But in the inverter side, nothing will happen.
Okay.
If they do not have the grid feedback.
Yeah, we will explore this topic in next videos also. I mean, how this concept particular thing is going on when solar cells are still generating. If you are not using, what is the things happening? We will discuss in a complete next session also. Very nice. Okay. I think can you speak few things about? I think ash handling related. You have so many projects. Can you what is the project generally? What is your task? What you
basically that particular company, DC Industrial Plant Services, they were doing EPC for ash handling system in thermal power plants, mostly thermal power plants of NTPC, National Thermal Power Corporation.
Yeah.
So so our job started from ESP. I mean, like when the coal is getting burned in the boiler. So I think 3 kind of ashes were getting produced, like unburnt coal, fly ash. So and it was like if I remember correctly, that is a long ago. So what happened was there, like the bottom ash hoppers were there, which were collecting the unburnt coals from. They were big size. Because the coal was half burnt.
Yeah.
Fly ash, it is going to ESP.
Yes.
Electrostatic precipitator.
Yeah.
And there were HCSD system where the ash is coming and getting in the form of a slurry, which is getting into ash dike.
Okay.
Ash dike. And also there was like fly ash silos where fly ash is getting stored, and it is carried away by trucks. Because those ash are used for making bricks.
Yes. Cement also sometimes. Yeah. Okay. So whatever coal is there, unburnt coal, it is very hot, but it's still unburnt, half burnt we can say otherwise. So what they will do? They will bring out and process it and put it again, or what is the process?
No question of putting it inside the process again. The unburnt coal, the bottom ash hoppers were there. Then since they were of big size, the crushers were there. So they were crushing the unburnt thing and making it go away like in the slurry or something like that.
Okay.
No question of putting them back into the system.
Okay. Very nice. Very good, Chakrabarti. So your exposure, something you shared today, it's very nice. These things, I think, even though it is a general chit chat, but it will help some people how things are there in the practical world like that. Yeah, this is not the end. We are going to do many more videos also in the future. Small topics I will choose based on your understanding, exposure, experience. So those things we will discuss. Yeah, you delivered it in a clear manner. Very nice. Thank you. Thanks a lot for accepting and presenting today. Very good, Chakrabarti. Yeah. Bye. See you in next video. Yeah. Good. Thank you, friends. Thanks for watching. This is about Mr. Chakrabarti. I think the information may be helpful to you. If you have any questions or comments or anything, then please comment in comment section. so that I can give answers to those. If you are watching this video for the first time, then please subscribe to this channel so that whenever I'm posting any videos, you will get notifications. Thank you. Thanks for watching. We will meet in next video. Bye.